Hi, and welcome to Better Code Today. My name's Tim Neal, and today I'm going to be talking about C# constructors. So a constructor is a special method that's used to initialize a new instance of a class. It gets called once when a class is constructed using the new keyword. Like any other method, it can take any number of parameters as well as an access modifier. That is, we can put limits on what code is allowed to call our constructor. To help you out, if you don't specify any constructors at all for a class, the .NET Framework will automatically create a public parameterless constructor for you that doesn't explicitly do anything except allow the class to be instantiated. There are also such things as static constructors, although these are used much less often. These are used to set up any static fields on the class. They aren't explicitly called by your own code, but the .NET Framework will call them once per application instance and before the first time an instance of your class is created. Static constructors can access any static fields or methods on the class, but nothing tied to a specific instance. As we don't call it explicitly, we can't pass any parameters to the static constructor, and you also can't set an access modifier on it. As it turns out, you don't always need a constructor to set the initial value of a field. You can also use an initializer so that when you define the field, you immediately set its value. This can be a fixed value, or you can call a static method to get the value. What you can't do is set the value based on any external value which might be passed in. If you need to do this, you really do need a constructor. There's no reason why you can't use both initializers and constructors in the same class to set different fields, although if you do this, you should be careful to make sure that the code remains readable and it's easy to see what gets set where. So let's have a quick look at the concepts we've talked about so far. So here I've created a simple empty class, and you will see in the program method that I can create an instance of that class even though I haven't created a constructor. Now, if we switch back to the simple class, I can add in a private constructor. And now if we try to rebuild, you will see that we get an error because although previously we were getting a default parameterless public constructor, now we only have the private constructor that I explicitly created, which is not accessible from our program class. So let's change the constructor back to public and give the class a few private fields. So we'll create a static field and a non-static field. Now we can create a static constructor to initialize the static field. We do this simply as so. And you'll see if I try and give the static constructor a access modifier, the code will no longer build, so we can remove that. And if I try and pass in any parameters, again, the code will not build. The error message is quite self-explanatory, so it's very easy to see what you've done wrong here. So let's remove that. And what the static constructor can do is set any static fields like so. You'll see if I try and set field 2, again, you'll get an error. Another thing I can do is create a static method to set the variable, and I can access that. And that will compile just fine. So if we want to set the instance field, we have to do that from within the instance constructor. So we can easily do that here. We can also set the static field here. However, that is quite risky because the constructor will get called every time we create a new instance of the object. And if a previous instance is using the static field, it will get reset, which may not be what you want. So let's remove that. Again, from within the constructor, we could call a method to set the field. And unlike in the static constructor, it could be a non-static method now. So you'll see from the instance constructor, I can call the setField instance method. However, I cannot do the same thing from the static constructor. because it requires an instance of the object, which we don't have at the time we're running the static constructor. So if I undo that, the other way we can set fields is using an initializer, as I mentioned earlier. So we can explicitly say field 1 is 4, field 2 is 5, like so. We can also call the initialization methods from here to return the value. Set field, set field. They can both access the static method. However, if we wanted to use the instance method, we will see, in fact, it doesn't work for either of them. This is because the initializers can only access static methods and fields, although they can set an instance field. So let's set that back how it was. Now you might be wondering, with all these different ways to set a class's fields, what order will everything happen in? Well, if you look at this class I wrote earlier, it will help us to find out. It has 4 fields, 2 static and 2 non-static, and for each pair, the first is set using an initializer and the second using the appropriate constructor. Each time we set a field, we call this static method report and return string, which will tell us what we're initializing by writing to the console. As you'll see here, I'm going to instantiate 2 instances of the order class, and we will see what happens when. So if I run this code now, you will see that, as expected, the static initializer and constructor run first and only run once, even though we instantiated 2 instances of the class. And you will also see that the initializer runs before the constructor in all cases. As I mentioned earlier, instance constructors can take access modifiers to allow us to control what code can call them. We can set a constructor to be private so that only the class itself can call it. Of course, if a class only has private constructors, it can be difficult to construct it, but that might be what you want if you're doing something like creating a singleton when you would actually use a static method or field to construct the object. There's also no reason why you can't have a class with a mix of constructors, so that it has an externally accessible constructor and a private constructor, so that the class can create new instances of itself in a different way to how we want external code to do it. The only limitation is that, like methods, you can't have 2 constructors that differ only in their access modifier. Each constructor must take a different set of parameters. Moving on, you might also create a protector constructor so that derived classes can call that constructor on the base class, but nothing else can. Again, it might be useful to have derived classes construct the base class in a different way to how you want unrelated external code to do this. Internal constructors can only be called from within the assembly they're defined in, and it's quite valid to have just an internal constructor on a public class. If you do that, then the class can only be instantiated from within the assembly it's defined in. But once this has been done, the instance can be passed out to be used in any code in external assemblies. Public constructors can, of course, be called from anywhere. And as I mentioned just now, you may well have a class with a public constructor that allows external code to initialize it, and a private or protector constructor so that the class or any derived child classes can create new instances of themselves in a slightly different way. It's also quite possible and indeed common to have more than one constructor of any access type so that the class can be constructed differently depending on what data you have available to pass into that constructor. When you have a class that derives from a base class, to instantiate the derived class, you must also instantiate the base class, which means calling a constructor on that base class. If the base class has a parameterless constructor that is accessible from the derived class, then the framework will call this by default if you don't explicitly call a different constructor. But you can also call any accessible constructor of your choice explicitly using the base keyword. If the class doesn't have any parameterless constructors that are accessible from your derived class, then you must explicitly call a constructor and pass in the required parameters. Another thing you can do in a class with more than one constructor is call one constructor from another using the this keyword. This can only be done at the start of the constructor declaration. You can't choose when you want to call the other constructor, but this will allow you to have multiple constructors which initialize the same fields without having to duplicate the field initialization in each one. Okay, so now let's have a quick look at what we can do with these ideas. So here you can see we have a base class with 3 instance fields. The first is set using an initializer, the second set in a public parameterless constructor, and the third in a public constructor with a single string parameter. You'll also see that we're setting the fields using the report and return string method we used in the previous demo. And here is the derived class. It has 2 fields of its own, the first set using an initializer and the second in the constructor. Again, we're using the report and return string method, which is accessible from this class because it's a protected method on the base class. You'll notice we aren't explicitly calling any constructors on the base class. I've modified the program to create a single instance of the derived class, so let's run it and see what happens. Okay, so there's a few interesting things here. Firstly, even though we don't explicitly call a constructor on the base class from our derived class, you'll see that the parameterless base constructor gets called, as I mentioned earlier in the presentation. The other interesting thing is the ordering. You'll see that first it calls the initializer on the derived class, then the initializer on the base class, then the constructor on the base class, and the constructor on the derived class. So we can see that initializers always run before constructors, but initializers and constructors run in the opposite order. Initializers run from the most derived class back up to the base class, whereas constructors run with the base constructor first and then working down to the constructor on the most derived class. Okay, so now let's make a quick change to the code of the base class. We're going to comment out the parameterless constructor and recompile, and you'll see that we get an error. Because we don't have a parameterless constructor on the base class anymore, the derived class doesn't know how to instantiate the base. We need to explicitly tell it which constructor to call and what to pass to it. So we can do that now. We use the base keyword to call a constructor on the base class and pass it a value for the parameter. Now it can be hard-coded as here, or we could add a parameter to the constructor for the derived class that we would pass directly through to the base. So if we compile again, we'll see that it works, no problem. And if we run the code, you'll see that everything is pretty much the same, except that we're calling the parameter constructor rather than the parameterless one. All the ordering is exactly as it was before. So now let's uncomment the parameterless constructor again and run the code once more. And you'll see that absolutely nothing has changed this time. Even though we have a parameterless constructor, because we're explicitly calling the other constructor with the string parameter, we will not actually use the parameterless constructor at all. If we wanted to call both constructors, we would have to use constructor chaining. To do that, we add this keyword to the definition of the parameter constructor. And because we don't have any parameters for the constructor we want to call, we don't have to pass anything in here. Of course, we could do this in the opposite order and call the parametered constructor from the parameterless one, but then we would need to find a string value to pass into it. And if we run the code again, we will see that now we are calling both constructors, the parameterless one first and then the one with a parameter. And that's all we have time for today. Hopefully you now have a richer understanding of how constructors work in the C# language and some of the different things that can be achieved with them. We really hope you enjoyed the video and found it useful. If you did, why not subscribe to our YouTube channel or follow us on Twitter. Thanks for watching.